The gateway signs every internal token with a private key, which means sooner or later you have to rotate that key because keys expire, keys can leak, and good security policy demands it. But here's the trap. If you just swap the signing key, every token already in flight, signed with the old one, suddenly fails to verify, and requests start getting rejected. So how do you rotate the key without dropping a single request? That's today. First, the problem, clearly. A signing key is a secret, and secrets have to be rotated on a regular schedule and immediately if one ever leaks. But remember, our tokens live for a few minutes. So at the exact moment you rotate, there are always valid tokens out there, signed with the key you're about to retire. If you just swap the key naively, delete the old, install the new, every one of those in-flight tokens fails verification the instant it lands. You'd take a self-inflicted outage on every single rotation. We need something smoother. The foundation is a standard called JWKS, a JSON web key set. Instead of copying public keys around by hand, the gateway publishes its public keys at a well-known URL. Each service is configured with just the gateway's address, and it fetches those keys automatically and refetches them when they change. No manual key distribution ever. And every key carries a key ID, a KID, which is stamped into each token's header. So a service always knows exactly which key should verify a given token. That last detail is what makes smooth rotation possible. Here's the trick, and it's elegant. During rotation, you publish both keys at once, the new one and the old one, side by side in the key set. That's your overlap window. You start signing brand new tokens with the new key, but the old key is still published, so every token already in flight, signed with the old key, still verifies perfectly. You wait out the token lifetime, just a few minutes, until every old token has expired on its own, and only then do you drop the old key. At no point is any valid token rejected. That is zero downtime rotation. In Trellis, this is mostly configuration. On the gateway, one line publishes the discovery document and the key set. The public keys services will fetch. When you rotate, you set signing credentials to the new key, and you move the old key into previous signing keys, published in the key set, but never used to sign anything new. And downstream, a single line, authority equals the gateway. Each service fetches the key set, and when a token arrives with a KID it hasn't seen, it refreshes automatically. The whole rotation is a config change plus a short wait. One honest, important note, getting the sequence right matters. The safe runbook is, first, pre-publish the new key in the key set while you're still signing with the old one. Second, probe every service, actually confirming each one has fetched and can see the new key. Only once they've all converged do you flip to signing with the new key. Then you keep the old key published for one more token lifetime, and finally drop it. The dangerous shortcut is flipping the signing key before your services have seen the new one. Do that, and you're right back to rejected requests. Publish, probe, flip, drop, in that order. So key rotation doesn't have to mean downtime. Publish your public keys as a discovery document. Let every service fetch them automatically. And when it's time to rotate, overlap, publish the new key alongside the old, sign with the new, and wait for the old tokens to expire before dropping it. KID-aware key sets make it seamless. Next time, we add a dimension every real system needs from day one: multi-tenancy, keeping one customer's data provably separate from another's. Subscribe, and I'll see you there.